This is Ralph Lemmel, and today I want to do a little re-engineering experiment with the 101 Companies project. So we will pick a XML based 101 implementation that involves XML documents, XML schemas, XSLT programs with some dependencies between these artifacts. And we want to illustrate how we can transform, if you like, refactor these artifacts by a sort of a coupled transformation, in the sense that multiple artifacts have to be changed simultaneously. Okay, so this is the implementation that we pick, 101 implementation XSLT. So let's go to the wiki page and have a look. So here we are. So this is the implementation. As you see, the implementation involves XML, XSD for the schema language, and XSLT for the program code. Okay, and in terms of features, well, we implement tree structure unavoidably because we work some XML document for companies. Okay, we implement type-driven query to total salaries, type-driven transformation to cut salaries, and some more stuff. Okay, so let's just have a quick look on GitHub to see the artifacts here. Okay, so as usual, there's the sample company. Okay, and there's the schema which defines what companies look like, and then you see there's all kinds of XSLT programs here. For example, we have cut XSLT, which is the program, using some templates to essentially transform the company by matching salaries and dividing the value for the salary by 2. Okay, so this is the implementation that we want to re-engineer. We want to basically do something really simple. We want to rename salary to income. Okay, so as I was already starting to explain, there are 3 levels: instance level, the actual company documents; schema level, the schema of company documents; and a program level, things like cut.xslt or other XSLT transformations implementing some functionality. So we have to perform renaming at all 3 levels. Just to illustrate this a little bit more, here we look at the instance level, right? So this is some fragment from the company sample, and so you see that we use the salary tag here, and of course the renaming requires that this becomes an income tag. Okay, for the schema level, we of course define a corresponding type here, an element declaration that describes what salaries are about, and this is here's the declaration, and here we refer to that declaration. So obviously, if you do the renaming at a schema level, it means that we also need to rename these declarations and references. And then at the program level, there are multiple idioms that could involve references to certain tags like salary. Here we show one template indeed from the XSLT program for cutting salaries. So we match on salaries here, right? And so we even have to be careful about how we deal with namespaces here and all that. So again, if you do renaming here, you also have to replace that sort of tag. Okay, so there's an implementation of this transformation. It's available online. Here's just a quick description of how it works. I mean, there's many ways of doing it. For example, some people might want to use XSLT. What I have done here in this experiment, I have used Java, and I've used the JDOM API for in-memory XML processing to actually operate on XML documents, XML schemas, XSLT programs, which happen to be all represented in XML. So actually, the instance level of the renaming is rather straightforward, right? I mean, if you know how to cut or to total salaries, we also know how to replace the salary tag by income tag, right? So the type level is already a little bit more complicated because we obviously have to understand XML schema, and we have to know about declarations versus references, but nevertheless we can describe this as an XML transformation. And at the program level becomes even more complicated because XSLT is a relatively full-fledged programming language, so we have to think about the relevant idioms here that we might need to handle in terms of renaming. Okay, So again, the implementation is available online, and if you are familiar with JIT, you can just clone it or you just browse it online. That's what we will do here. So there's essentially one key file here that implements the refactoring, the renaming. So this is the Java code here. So let's just look at it. So basically, as you see here, we have 3 methods here in this file: instance level, type level, and program level. So the code gets increasingly more complicated the higher the level, right? So we can just have a quick look at, let's say, the instance level. This is really very straightforward DOM-like code, right? So it's very much similar to actually the implementation of cut. When you would do it in DOM, we try to find all the occurrences of the old tag, right? And then we basically replace that tag with the new tag. So this is completely parameterized in the namespace on which we operate. The old name, the new name, we apply to a document according to the DOM API. Now we could also look at the other levels here, but this gets increasingly more complicated. So unless you are sort of a DOM nerd, this is not going to be very exciting. But just to give you an idea, right? So at the schema level, what we have to do is, well, we have to get to all XML elements that have element as a tag, because this is how element declarations and element references reveal themselves in XML schema. And then we have to deal differently with the actual element declarations, which we can determine because they have a name attribute, and with the actual element references, which instead have a ref attribute. And then we do some magic about all the namespaces and all the replacements, and that's it. And you see the code for the program level is even more complicated, so I skip it here. And I don't even claim that this is a complete implementation, but it's certainly good enough for an illustration. So indeed, I want to make a disclaimer here. This is just an illustration to show you a simple re-engineering problem, and specifically to explain a little bit what some people call couple transformations. It's pretty low level, pretty ad hoc. I mean, given how I do it in JDOM, in Java, in imperative code. It's certainly not complete in terms of the XSLT patterns that could require some renaming, okay? And also the way how I do some of the renaming here, especially at the XSLT level, it's not totally safe. You are welcome to make improvements. If you want to know more about coupled software transformations, one thing I want to point you to is the coupled software transformations workshop 2011 that we did at JITC last year, or also just to have a data point on some research results. There's nice work by Joost Visser and others doing some forms of coupled transformations in a much less ad hoc and much more high level way. Okay, so what's the point of this demo? I want to demonstrate you how you can use 101 companies for some re-engineering experiments, right? So 101 companies, even though originally it was meant to just illustrate languages and technologies, it has some meta-level value because it's really a corpus of all kinds of implementations. Now we can do data mining, reverse engineering, re-engineering with it. And so I also show you how easily you can get started with re-engineering. So this took me like 2 hours to implement this experiment. And so hopefully you're motivated to do other re-engineering experiments. Thanks for listening. Here are some pointers if you want to get in touch, and everything regarding this presentation is available online on GitHub. Thanks.